What's that question?
Alright, great things. I want to start with the back of the text. You have to do exercise 4.4, number 1 and number 9. Let me know if you didn't get the correct answer and what we should go through exercise. Number 1 and number 9, those are the little equation questions. Those ones where you have to make a specific variable the subject. So the answers are at the back of the textbook. If you don't have your textbook, you need to look at the one on exercise 4.4.
Just kidding.
No, except when you know, if you wanted to work through any of those questions specifically, some of them were quite tricky. Like towards the end of number 1, maybe, and maybe in number 9, you didn't know exactly how to get going. So you can just ask me once you've looked at the answers. Did you post that exercise? The one on Tuesday. Is that the day one? So we will go with the
The table has 2b minus 3a over a. Two examples.
3b over a minus 3b.
Sorry, yeah, 2 over a minus.
Yeah. Yeah.
Just
Yeah.
if you have a negative denominator,
Mhm.
you have to multiply the next one. So
So they have multiple terms.
yeah, I did have multiple terms. I had 3a
Which question is it?
2b over negative a, and the textbook said the answer was 2b minus 3a over a, which is the same because I have to go the extra step and multiply by next one.
It is, yeah, they usually do that, but
Okay.
but we tend to accept both options because it's not really wrong. It's just, I suppose, a bit neater if you don't have a negative number in your denominator.
I wrote it as 2 open bracket and say minus.
Okay.
Greater than or
Unless they say that you have to write your answer as one fraction or something like that. This is an instruction here. Any other questions, guys? Any of those you want me to go through? If I see? I don't know. And guys, if you're marking, right, and you see that maybe your answer is very similar to the answer at the back of the book, but it's not exactly the same, you might be able to identify what your mistake was. Right, so look through your working again. It is better if you actually can identify your specific mistake instead of just being like, oh, I did this wrong. All right, so that you can fix that mistake in future. Number 9, were you guys able to do number 9? Right, you have to square both sides. Did you think about doing that?
Yeah.
Okay, there's a request for me to go through 1J, and then I think I'll do 9 as well. All right, if you got these correct, then don't worry, I'm just doing this one for those of you that didn't. Okay, so that is the equation that's given in 1J. Okay, now they want us to make x the subject of the formula. We have a whole bunch of x's, but first let's get rid of our denominators. All right, that's what we always do when we have an equation with fractions. So the LCD here, remember we're going to have to multiply each term by the LCD for an equation with fractions. The LCD is x minus b, x minus a. All right, so we all find that the LCD is those two brackets. All right, so we need to multiply this one by x minus b, x minus a. And the next term by x minus b, x minus a. And the last term, which is two terms already, so I'm just putting brackets around those. I must multiply those two terms also by x minus b, x minus a. All right, now we can look at what's going to cancel out. From my first term, the x minus b's are going to cancel out. So I'm going to be left with a times x minus a, that first term, minus b times, let's take a look, the x minus a we're going to cancel out. I'm going to be left with x minus b is equal to, and in this case, both of the brackets are going to cancel out. So I'm just going to actually be left with a minus b. So sorry, those brackets weren't really necessary. But if there was something that didn't cancel out, you would have had to leave those brackets around the original number. Okay, so now we'll just have to multiply out ax minus a squared minus bx plus b squared is equal to a minus b. Right, now guys, we're supposed to solve for x. So we have x's there. So you actually have multiple things that you could do here. You obviously have to group these two terms together, right, and take out an x as a common factor from there. But on the other side, you could have now moved the minus a squared and the plus b squared over to the other side and then grouped on this side. Or you can group these two terms together here, right? Do we agree that it's b squared minus a squared? So it doesn't really matter where you do that factorizing. I'm going to do it on the left-hand side. This is b plus a, b minus a, right? The difference is two squares there. But like I said, you could have moved it over and then done a difference in two squares on the other side by grouping those. Now, I would like to take out this as a common factor, but can I at the moment? No, I have to first do a switch around, right? Which you could have done all in one step if you would recognize that already. So this is going to be the b plus a. You can leave it as b plus a. You can write it as a plus b. It doesn't matter. But this one is then going to become a minus b. Now I can take it out as a common bracket. Guys, if you moved it across and factorize that difference of two squares on this side, you would have taken out a minus b as a common bracket on that side. Okay, which is fine. You'll get the same answer. So you are then going to be left with x minus this bracket a plus b, right? Which is going to actually be a minus b. You guys see what I'm doing there? On my first term, when I divide by this bracket, I'm left with x. Are we all fine? From the second term, I'm going to be left with minus, in brackets, a plus b. So I just multiplied that minus in already. Okay, that's how I got that. Okay, what's going to happen here? With this a minus b. If I do this, x minus a minus b equals a minus b over a minus b. What's anything divided by itself? 1. So I'm going to have x minus a minus b equals 1. And guys, in this case, I can do that because the a and the b, that's not the variable that I'm solving for. I think we had a conversation, I'm not sure now when exactly that was, that you can't divide through by a negative. We can talk about that because then you're canceling out one of the solutions. Was that with you guys? No, okay. It must have been with mine. 12 maybe. Sometimes when you're taking out like x as a common factor, people are inclined to take the x over to the other side and say 0 divided by x is 0. So they throw that x away. You can't do that because x is going to give you one of your solutions. In this case, I wouldn't be able to divide through by an x, but I can divide through by an a minus b because it's not the variable that I'm solving. I'll see if that comes up. It should come up in another example somewhere along the line, and we'll talk about it again. But now to get x on its own, I just need to move the minus a and the minus b across. So x is going to be 1 plus a plus b. Is that what we got at the back of the book?
Yeah.
And obviously, those three terms, you can also change the order. It can be a plus b plus 1, or a plus 1 plus b, whatever, as long as those three terms are there. Okay, so that was one way of doing it, guys, where you factorized, where you grouped basically on the left-hand side. But like I said, from this step here, you could have moved your minus a squared and your plus b squared to that side, and then you could have done grouping there. Okay, in which case we would have gotten the same answer.
That feels like
Yeah, you wouldn't have had to do a switch around. I'll get there soon. All right, for number 9, let me just quickly show you what you have to do in number 9. So the equation was d equals the square root of WL over 15b. And they wanted you to make b the subject of the formula. So obviously we're going to have to get rid of the square root. All right, now you guys haven't done third equations yet. We only have to do that in grade 11. But I think you can figure out, in trying to get rid of the square root, do you agree that you have to square it? So the square root and a square cancel each other out. So you would have to square this side and then square the other side as well. Remember, in an equation, you can do anything to the equation as long as you do the same thing on the other side. All right? So I'm going to have d squared equal to, now the square root and the square will cancel each other out. So WL over 15b. I want to solve for b, right? So I want to get rid of it there. I don't want it in the denominator. So I can multiply the other side by 15b. So I'm going to have 15b d squared equal to WL. Right? And to get b on its own, I just need to now get rid of the 15 and the d squared. So I can then just say that b is equal to WL over 15 d squared. Is that what they got at the back of the book? Right, so guys, unfortunately, if you didn't think of doing this, then you wouldn't have been able to go further, really. Any other questions on this exercise? Okay, you also have to do 1K and O from exercise 4.5, so mark those ones quickly. 1K and O. Let me know if you have questions. Were you able to do K? Yes? Yes, yeah, the request has already been made that I do O. All right, so 1 O. Did you not give me something? I thought you gave me something. Okay. Okay. All right, 1 O. 2x times x plus 5 minus 3 times x plus 2 is equal to 9. Okay, now guys, obviously here I'm going to have to multiply the brackets off. Guys, there's nothing else that I can do. Maybe if you had the same two brackets, you could have taken that out as a common factor, all right? But the fact that we have a 9 on that side, the fact that there isn't a 0 on that side means that we actually do have to multiply out. Okay, remember for a quadratic equation, you see that this is going to be a quadratic equation. When I say 2x times x, that is going to give me an x squared term, right? For a quadratic equation, we have to get everything on the one side equal to 0. Okay, so 2x squared plus 10x minus 3x minus 6 minus 9 is equal to 0. Okay, so I'm multiplying out those brackets, and I'm bringing the 9 over at the same time. So 2x squared, this is plus 7x, and then minus 15 equal to 0. That's a trinomial, right? We need to now factorize that. Okay, what brackets did you guys get from that? 2x minus 3 and x plus 5, does that work? Okay, let's see. 2x times x is 2x squared. When we do our outwards, we get plus 10x. Then we get minus 3x. That will give us 7x, right? And negative 3 times positive 5 will give us negative 15. Now, when you have your two brackets equal to 0, remember you make each bracket equal to 0 separately and solve. So you're going to say the first bracket equal to 0 or the second bracket equal to 0. So this minus 3 is going to move across, it's going to become positive 3, and then you have to divide by 2. Right, from the other one, you're going to get x equals negative 5. As I think I said 2 days ago already, that you can go straight from your brackets to your two answers if you're able to do that in your head. Is there a mistake in the book?
Yeah.
You know what, yeah, maybe 5 and 9.
Okay, guys, if it says positive 5, you just put a minus in front of it now quickly. There's obviously a printing mistake in some of them. But the 5 was fine. Yeah, sorry, yeah.
So can you like
You can go straight from the brackets to the answers. Fine. Okay, guys, simultaneous equation. We have already done it in 8, but now we're going to do a proper note and practice.
tomorrow at
7:45.
tomorrow in math.
Again, here, but
First period.
quarter to 8.
What's the first?
Yeah.
Yes, hence you have to be at quarter to 8. So that you can start writing at 8 if very well.
And the your class.
Okay, I'm going to
Sorry.
start charging you money every time. That's clear, thank you. I made that assumption. All right, so the first method is substitution. And guys, to be honest, substitution is the method that I always use. I don't really like elimination. There's nothing wrong with elimination. I just prefer substitution. I find it faster. In some cases, elimination is quicker, but not always. We have done one example on each of them, so we're just going to write it down now again. Okay, so, yeah. So for x and y. Now guys, the way that I write it out when I'm doing substitution, I always write the one equation on the one side and then the second equation on the other side, because I like work underneath each one. But you can do it in whichever way you want. It doesn't matter. You don't have to write it out like I do. So x plus 2, y equals 5. That's the one equation that's given. And the other one is x minus y equals negative 1. Okay, so I'm actually going to write down the steps. And then we're going to do the steps underneath each part that's written. Okay, so step 1 will be to isolate. isolate one of the variables in one of the equations. So guys, basically for any simultaneous equations question, there are four possible solutions, four possible working, right? Because in the first equation, you can decide to make x the subject, or you can decide to make y the subject. That will be two different methods. Or you can decide to make x the subject in the second equation, or you can decide to make y the subject in the second equation. Right, you actually have four to choose from here. Now you always go for the easiest one, the one that will require the least amount of steps. Right, so in this case, there are two options that will have the same number of steps. You can either make x the subject in the first equation. How will I do that? I just need to move my plus 2y to the other side. Or I can make x the subject here. How would I do that? I need to move my minus y to the other side. All right. I usually start with the first equation just because I like it written out in a certain way, but it's up to you, okay? So I'm going to make x the subject there. But I'm not going to make y the subject because if I do that, I have to move the x and then I must divide by 2, which is going to give me fractions. Yeah, we want to try and avoid fractions as far as possible. So I'm going to make x the subject here. I'm going to say x is equal to 5 minus 2y. That is going to get you your first mark. Step 2. This is now where the substitution part comes in. Replace that variable, so the variable that you chose to isolate, so x in this case, replace that variable in the other equation with the expression found in step 1. Okay, so I found x, right? I isolated x. So now in the other equation, we're going to replace the x with 5 minus 2y, right? Just like what we did in AP. So that is now going to become 5 minus 2y. So this is not why I do it like in 2 columns, because now this I'm going to do underneath the x minus y. All right, so here I'm going to write 5 minus 2y instead of x. I'm writing what x is equal to according to my formula, basically, that I made in step 1. So x minus y, so I'm going to still do minus y, equals negative 1. Let's just underline this 5 minus 2y again, just so that you remember that that is x. All right, all three of these things are equal. I'm replacing the x with 5 minus 2y, yes? No, because usually this would be right underneath it. So, but you do have to show x as this and then do your substitution. Yes, yeah, you get a mark for each of those. So this will be your second mark, guys. Wherever I'm putting ticks, you have to write down that step. Okay, you get marks for those steps specifically. Now, like we saw in AP, we now only have one variable, right? We only have a y. We don't have x anymore. So now we can solve for y. I'm going to say negative 3y. Right, negative 2y minus y is negative 3y. I have negative 1 minus 5, that's negative 6. So then y is equal to 2. That is the third mark. We're getting the actual value of y. Okay, then step 3 is going to be to then use the value found in step 2, right? The value for y in this example, but you might do it the other way around. So whatever value you're finding in step 2, you need to then put that back into the expression that you got in step 1. That's going to give you the value of x. Okay, so use the value found in step 2 in the expression found in step 1. Sorry, it is very wordy. I don't really know how to explain it in a shorter way. Found in step 1 to calculate the other variable.
That only says that.
So we're gonna find x now. No, we found an expression for x, but we didn't find the actual value for it. We need to find a number for x and a number for y. Okay, guys, so I'm just gonna rewrite this expression that we got. 5 minus 2y, but now y is equal to 2. So x is going to be equal to 5 minus 2 times 2 instead of y. And what's that? 5 minus 4, that is 1. That will be your fourth mark. So guys, that means that these two values, right, if x is 1 and y equals 2, these two values will make both of these equations true. Let's check quickly. X is 1, right? So that's 1 plus 2 times 2. Does that equal 5? Yes. All right, let's check for this one. X is 1 and y is 2. 1 minus 2, that is negative 1. Okay, so by using both equations, right, we did some work in the one equation, then we moved across to the other one, then we moved back to the first one, we are getting values that satisfy both of those original things. Okay, so that is substitution, guys. So obviously when you're writing this down, you're not going to write down step 1 as this and then do step 1 like we did now, right? You're just going to do the actual working. So you'll practice that, and you have practiced it in 8 before. Was it okay when you've done it before? Kind of. Now you have the steps written down, so you can refer back to those. All right, but let's quickly do an example on elimination. And guys, we are not going to tell you that you must use either substitution or elimination. You can decide. In fact, some of the other classes aren't even going to get to elimination. In some cases, yeah. Okay, guys, we are going to do the same. We're actually going to do the same two equations now. Now, when you're doing elimination, you're not going to write them in two columns. You're going to write them one and like underneath each other. So you're going to have x plus 2y equals 5, and then you have x minus y equals negative 1. Because I don't know if you remember from AP, when we marked that first question, I think it was 4A, we did where you like adding or you're subtracting the equations from each other. Okay, so that's what we're going to do here. So guys, for elimination, basically you're going to have to look at your variables and you're going to see whether one of the variables in the one equation is a multiple of that same variable in the other equation. For this one, do you see that we have an x and an x already? So what I'm going to do for this one, actually, just take a different color. I'm just going to minus the second equation from the first equation. Because that will eliminate the x's. Because x minus x is 0. All right, so for elimination, we're going to do a couple of examples. Two separate equations, yes. So for elimination, guys, there are lots of different things that you could have done. You also could have just said I'm multiplying this equation by -1 and then added them together. Okay, we'll talk about that later. But here, because you can see that if you just take the top equation and you minus the bottom equation from it, you're going to have x minus x, which is 0. Okay, so take your ruler, draw a line underneath it. X minus x is 0, which you don't have to write.
Oh,
Yes, so if you just give me a chance to actually speak, then maybe you'll understand. Then we have 2y minus -1. So now we must be careful, hey? 2y minus -1, that's going to be 2y plus 1. Right? So this is 3y equal to 5 minus -1 is 6. So just by doing that, we've eliminated x. All right, what is my y value here? 6 divided by 3, hey? Y is 2. Isn't that what we got in the other example? We're doing the same exact equation, right? We got that y is 2. So that is going to be your step 1, guys. I'm going to write it on the side here. Step 1. Okay, I'm going to say the coefficients of x are, let me just see if that on the page, are the same in both equations. Therefore, subtract one equation from the other to eliminate x. Yes.
Is it possible to, information, none of the questions for each other? Multiply the columns together, those from
Yeah,
multiple?
we're doing a example of that. And that's where it gets quite complicated, where I would rather just do that.
Yeah.
To be honest, yeah. Okay, so therefore subtract one equation from the other to eliminate x. Step 2 is then what we did here, solve for y. So guys, I'm not trying to write like general steps that will work for each equation because it will be so different. You'll see when we do some more examples now. So these are actually steps for this equation, for this set of equations. Okay, now for step 3, guys, we have y, we still need to find x. Now in this case, we don't have an x equals whatever, like we did in the substitution method, right? In substitution method, our first step was get x on its own by moving everything over to the other side. Then we use that in the last step to get our x value. So now in step 3, you are just going to have to choose one of your two equations and sub in your y value that we just got into one of those two equations and then solve for it. Okay, so step 3 is going to be choose one of the original equations sub in the y value and solve for x. Okay, so which equation would you guys like to work with? The first one or the second one? First one, okay. So guys, you can also work with the second one. All right, you'll get the same answer. So for step 3, I'm just going to write it here next to step 3. I'm choosing x plus 2y equals 5. Just rewriting that equation. Now instead of y, I'm going to use the actual value for y, which was 2. So I'm going to say x plus 2 times 2 equals 5. So that's x plus 4. right? So when I move that plus 4 over to the other side, it's going to become minus 4. So we're going to have 5 minus 4, which is 1. Which is what we got when we did substitution. Okay, let's do another one. Number 2. We have 3x plus 2y equals 2. And then we have 5x minus 2y equals negative 18. We'll get to that. Well, not in this one, but we will do it in one. Now, guys, if we're looking at those lines, right? Do we see that we don't have exactly the same coefficients, but we actually have coefficients that will cancel each other out anyway, right? 2y minus 2y is just going to be 0. So in that case, when the coefficients are already canceling each other out, we are essentially adding the second equation to the first one. Two y plus negative 2y. That's what we're doing. Right? 2y plus minus, what's a positive times negative? A negative 2y minus 2y is 0. Okay, so if the coefficients are already canceling each other out, you're actually just adding the second one to the first one. All right, we don't have to change any signs. In the first equation, we have to minus the second one because I have to basically change the sign of x. I had to have a negative x. I had a positive x. All right, does it make sense why I multiplied this by negative 1? All right, for this one, I don't have to change the signs. The signs are already canceling each other out. So what is 3x plus 5x? 8x. 2y minus 2y is 0. You don't have to write it there. I'm just showing it so that you can see that that is what we're actually doing. And 2 minus 18 is negative 16. So 8x equals negative 16. What is x? Negative 2. Okay, now we need to choose an equation to sub this x value into in order to solve for y. And we do the first one again. Okay, so 3x plus 2y equals 2. I'm just rewriting it. You don't actually have to rewrite it if you don't want to. So now instead of x, I'm going to use the value for x, which is negative 2. So that's going to give me negative 6, right? When I move the negative 6, it's going to become plus 6. So I'm going to have 2 plus 6 on that side. So I have 2y equals 8. And then y is equal to 4. Okay. I'm sensing that you guys probably prefer a substitution, which is fine. I do as well. I'm just going to do one quickly where you actually have to do some multiplication. So 2x minus 3y equal to 10 and 4x plus 5y equal to 42. So guys, I want you to circle the 2x and the 4x because those ones are multiples of each other. So what I'm going to do so that my x's can cancel out, right? I need a 4x and I need a negative 4x. Does that make sense? Because I need 4x minus 4x. All right? Or minus 4x plus 4x. It can also work that way around. So guys, basically I want to turn this positive 2x into a negative 4x. So that my x's are going to cancel out. Does that make sense? What does I do to a 2x to turn it into negative 4x? Multiply by negative 2, hey? So now, yeah, you're gonna have to rewrite this thing because now we can't just, well, we can't just subtract or so on. So I normally say, yeah, some teachers will actually like label this as equation 1 and equation 2. I suppose it does make it a bit easier. So you're actually going to write down equation 1 multiplied by negative 2. Okay, it's good to show what you multiply by. Because I want it to be negative 4. That one. So that it will cancel out the positive 4x that I have. So I'm looking for the ones that are multiples of each other, and then I'm changing the smaller one so that it's just, it has the same value as the bigger one, but with an opposite sign, so that they'll cancel out. So 2x times negative 2 is negative 4x. Negative 3y times negative 2 is positive 6y equals 10 times negative 2 is negative 20. All right, so equation 1 I changed. I multiplied by negative 2. Equation 2 you are keeping the same. So you can just write 2 there so that you know what that is. Equation 2 was just 4x plus 5y equals 42. Now we see that negative 4x and positive 4x are going to cancel each other out. So I'm adding the second equation to the first one. If you want to, you can again put a plus there if you have space and put brackets around it. Negative 4x plus 4x is 0. 6y plus 5y is positive 11y. But you don't have to write that 0 plus, you're going to write 11y. Okay. And then negative 20 plus 42, 22. So y is equal to 2. Or, I don't want to confuse you guys now, but instead of multiplying equation 1 by negative 2, you could have just multiplied it by 2 to turn it into 4x, and then you could have subtracted the second equation from the first. Yeah, I'm going to say that again slowly. Instead of multiplying equation 1 by negative 2, you could have just multiplied it by positive 2, so that you have a 4x and a 4x. But then you would have had to subtract the second equation instead of adding it. Okay, if the signs are different, you add the second equation to the first one. If the signs are the same, you're going to have to subtract, all right, so that you have positive minus. Okay, now we need to again choose one of our original equations. I usually just go with the one that has like the smallest numbers, but it doesn't really matter. So I'm going to go with this one. 2x minus 3y is equal to 10. But now we put in our y value of 2 in the place of y. So minus 3 times 2 equals 10. So this is negative 6. When I move it, it's going to become positive 6. I'm going to have 2x equal to 16. So x is equal to 8. Can I just see by show of hands who is keen on actually using this method going forward? Okay, a couple of you. Yeah, when it's a very simple one. So like the first one, or even the second one, it is quicker than substitution. All right, but once it's getting to this point, I don't know if you are keen to do this, and especially when neither of the variables, or sorry, neither of the coefficients are actually multiples of each other. Because then you're going to have to multiply both equations by different numbers to get the same number. Do you want me to do an example like that? Or are you rather than just going to do substitution function? Yeah, for those ones. So what I'm referring to here is, I'm actually just going to show you in the book. is like this example here. Let me just zoom in a bit. So this is in the textbook, so you can look at it if you are keen again later on. So they have 5y plus 4x equals 9 and 4y minus 3x equals 32. So we see that 5y and 4y, those aren't multiples of each other. And then 4x and 3x, those are also not multiples of each other. So in this case, you need to look at your variables and you're going to have to try and you're going to have to multiply both equations by a number so that you get the same coefficient. So what they decided to do was, they decided because if you have a 4 and a 3, you can turn those both into 12, right? And the reason, guys, I think why they chose to do that with x instead of y is because there's a positive and a negative already. Okay, so the plus and the minus will cancel each other out. So you would multiply the first equation by 3, right? That will give you 15y plus 12x equals 27. Then you're going to multiply the second equation by 4. That's going to give you 16y minus 12x equals 128. And there your x's are going to cancel out. Okay. It's a bit more complicated, so you can use it there. But if it's a question like this, I would probably just use substitution. No, it is up to you. Yes. No, you don't have to. If you've written it down already in the question, then it's not. All right, guys, I'm going to give you a couple of these just to practice on your own. And for this now, you can use whichever method you want. You don't have to do a specific one. So it is exercise 4.9 on page 88. And this homework, guys, is for what's happening next week. Is something happening next week? I haven't had the testimony. Oh, no. So on, you can move it to Tuesday. No, we can't. So this homework is for Tuesday, all right? I'm not going to give you many, just a couple so you can practice these. Okay, number 2. Let's go with A, the first one, and then we can do D, and we can do A. So those are 3, and then in number 3, they have simultaneous equations that are more complicated. So it's basically equations with fractions that you first need to do that stuff. So you do have to practice some of those. So I'm going to give you an easier one first. So 3C, but then also 3D. Okay, so get going on that now. You have about 6 minutes. You can do the first one at least in that time. What order? No, do you have a textbook? I'm just asking.
I do.
So why is it needed here? Prominent.
I wrote it last week.
Oh, did you?
Yeah.
Okay. Not me.
That's easy.
Lost it. Okay, there you have 2 A's on the board there and 2 D. You have to do D. 2 A and D.
Yeah, 2A.
Okay. Okay, so K is not going to fit on the screen right now. I suppose I can move it down. Yeah, no, it still doesn't. All right, so 2A and 2D. I just want to make sure that you all know what is happening tomorrow. You need to be in the class at 7:45. Then we're going to do the whole setup thing. This is Glenda's class. We also need to wait for those kids to get ready, to be ready to start. And then there are a few people that are not in top six that have decided they want to do the Olympiad. They are going to be in this toughest classroom. So the 3 of us need to just make sure everyone's ready before I press start. Okay, so hopefully in that first 10 minutes, everyone will be ready because we did it already. What was it? On Monday, Tuesday, I don't remember now. Okay, it's going to be the same exact process. As soon as you guys are ready, you're going to write. It's going to be an hour and then you're done.